Alright, welcome to day 2, lesson 2. Today we're going to be solving linear equations. This will be like our 7th day of doing warm-ups, but you're going to see in the textbook all the warm-ups are kind of really some word problems and problem solving. Always make your best attempt at these. Since you're at home watching this video, just do your best and write your answer the questions, pause your video, and then when you're done, start back up again and I'll show you what I got here. Alright, let's see how you did here. So this guy's going kayaking, and he says he can determine the number of hours he can kayak for himself. Describe two different options. So he has 50 bucks. And so I kind of broke it up this way, which this took a long time. If I did a single kayak, I wrote an equation here, 15x, because it's 15 bucks an hour, and he has 50 bucks. So he could go for 3.3 hours. Well, you can't rent for 0.3 hours. So I said if he rents a single kayak, he could go for 3 hours. Did the same thing for the sea kayak, which you're going to have to start writing some equations. We don't know how many hours, but we do know it's $18 an hour. And so I divided both sides by 18, and I got 2.7 repeating. So that means he could rent that for 2 hours, this single kayak. And then the double kayak was 25 bucks an hour, and he probably used mental math for this one. He could do for 2 hours. Then it said Josh found out there's a $25 non-refundable, so that means it's a one-time fee. This happens in the real world all the time. When you have an air conditioner breakdown, they'll say, hey, you know what, we'll come fix it, but we're going to charge you 50 bucks just to show up, because we got to pay for our gas and time and getting there. And then if you say, no, I don't want you to fix it, well, they still got their time invested. And so a lot of times they'll charge you something up front, and then kind of if you decide to hire them, they'll give you a credit for it. This guy says, nope, $25 non-refundable. So that really means he only has $25 left. And so now you probably did mental math at this part, because if he has $25, he can only rent a single kayak for 1 hour. Oh, it says, how does the requirement change the mathematical situation? Well, instead of 50 bucks up here, I would put $25. And then I would do mental math. He could only rent that for 1 hour. He could only rent that for 1 hour. And he could only rent that one for 1 hour. So all of them, he could only rent for an hour at that point. Which method, choose efficient methods. How do the processes you use for part A and B differ? Pretty much up here I just use mental math on this guy, because I could easily do that in my head, but up here I had to write some equations. So how are they the same? How are they different and how are they the same? Part A, I wrote down equations. Part B, I did mental math. And then how are they the same? You could write equations for both if you wanted to, and that would be helping you to get the answer for both of them. So these guys, a lot of kids will just sit there during warm-ups, which really isn't helping you. Give it your best shot. I see the first 4 or 5 are really kind of challenging as far as thought process, and then they start getting a little bit easier. Give it your best shot, okay? So today we're going to start solving linear equations, and they do assume a whole lot. They do this first one in a kind of an interesting way. Well, they do all of them in the textbook in an interesting way, and I don't know if it's because of the way they're typing these out. The typing program will only allow them to do certain things. But what we're going to do is we're going to write the rule over here that allows us to do that. So it's kind of like a puzzle. You have to kind of figure out what did they do from this step to this step. Also notice that when we're writing the equations out and then the reasons, original equation is always the first step. So whatever the math problem is, we're going to write it right here, and then we're going to write the original equation. So we got to figure out what they did, and they did this in a unique way, because you see this 3 right here? The 3 has disappeared. So we got to figure out what they did with that 3, and right now it says this divided by 3. Now, not very many junior high teachers teach this as a first step or a step to get rid of denominators, but I like it. I learned later on in math that this is possible, but they're jumping right in. If you took each term up here, which I've been questioning you about terms for a couple of days now, if you multiply each term by 3, well, 3 over 3, so I want to put it here, 3 over 3 becomes 1. So that means this guy and this guy cancels out. Okay? So that just leaves us with 2x plus 4. So what we have to do is we have to figure out what did they do from this step to this step. Well, the rule says if you divide or multiply by 3, you have to do every term in the problem by 3. Okay, so that's kind of what they did, which is kind of unique. You don't see this very often. So 3 times negative 8 is negative 24, and 3 times 32 is 96. Now, what property did they just use? Well, we just multiplied everything by 3. So it's multiplication, property of equality. Now, equality means what I do to one side, I do to the other one. Okay? Alright? So now we have to figure out what went from this step to this step. So it looks like they multiplied everything in the parentheses by 2. Because 2 times x is 2x and 2 times 4. So that's what they did. So what did they do in 8th grade? In 7th grade, we call that distributive property. Now we're not going to put of equality because we didn't do it to both sides. Okay? And now what did they do? Well, you have to kind of look here. We got a 2x here. Looks to me like they did 2 steps at one time. It looks like they put these like terms together. So 8 minus 24. Is that what they did? Let's see here. They got 112 here somehow. So if I do 8 minus 24, I get 4. Nope, that's 38. That would be a negative 16. And so if I wanted to get rid of that negative 16, I'd add 16 to both sides. So let's see if that's what they did. 96 plus 16. That sure is 112. So what they did is they added 6. They collected these like terms and added them to both sides. So this would be addition, property of equality. And then the last step, I can clearly see what they did is they divided by 2 on both sides, and so this would be division, property of equality. Okay, so kind of some weird things here, or things to pay attention to. The rule always goes on the second line, so you have to figure out what they did here to get this, and then you write the rule. You have to figure out what they did here to get this. So they did the distributive property here to get this, but then I wrote distributive property down here. So it's kind of like one step behind over here. Okay? Alright, takes a little practice on that one. That's a unique way to get rid of denominators in a math problem. So here they're doing it again. They said, you know what, multiply all the terms by 3 first. And so that's what we want to do here. So now they're asking us to solve these problems. So 3, and I like showing your work like this. Okay, show step by step. So I got 3 times everything there. So now I got still 2 times 56 plus 4. And that's going to be minus 24, and 32 times 3 is 96. Now you got lots of things you can do here. You can put these two guys together and then multiply by 2, or you could take 2 times this. I know 54 plus 4 is 60, so I want to just write 60 there times 2. And notice I don't have any variables here because I'm just checking my solution. So I'm going to just kind of put these guys together. Multiplication is the next step. So that's 120, take away 24. And now 120 take away 24. Yep, 96 equals 96. So yeah, this is the solution here. This one says let's add 8 to both sides to be the first. So as we're older now, there's many different ways that you can go about solving equations, okay? So this guy says let's add 8 to both sides of the equation first. That would be the additive property of equality. Those guys go away. I still have the 2 times 56 plus 4, and I still have this 3. Now we want to get rid of that 3 in the denominator by multiplying both sides by 3. It's kind of what, this is the method you probably learned in junior high, like this one. 2 times 56 plus 4. 40 times 3 is 120. Notice how I'm using different colors for different steps. So as you're looking at my work, you can kind of follow along a little bit about where I did another step each time. So that works. I got 120 equals 120. So even though these were both the same problems, when I did all the work on the left-hand side, it equaled the amount that would be on the right-hand side. Okay. Same thing, I solved it differently. Got 2 different answers here, but what's on the left is the same as what's on the right. Okay. So that's kind of how we check our solutions. What's on the left has to be what's on the right. Alright, so here's a you try it. I don't care if you get rid of the 8 first. Oh wait, it says with application of addition property of equality. So we got to do the addition first. So don't forget, I want to help you here in a little bit. X plus 4 parentheses over 3. You have to write the original equation. And that's what we're going to write here, original equation. And now they made a special rule. They said, I want you to use addition property that begins with addition property. So you have to do that plus 8 first. Whoops, I'm going to squeeze it up here so that it kind of follows along. Plus 8, plus 8. And then show your line of what you get here, okay? Squeeze it in there. You're going to have to write small. So what do you got left here? Don't draw that little line there because you're going to run out of room. But over here you should say addition property of equality. Now don't forget, you're going to write your answer right here, what you got left. I want to do this real quick because it's our second problem. You still have this, and now 32 plus 8 is 40. Alright, what are you going to do next? Do it right here, showing your work. Put your answer right here, and then put your property over here. Alright, so pause your video, do those steps. I think I have enough lines right there for you to do all your work on. If not, just add another line. Okay? Alright, let's see how you did. See how I did it in different colors? So the next step you should have done was multiply both sides by 3, and I got this, so there's my rule. Then I divided by both sides by 2, because you can't do any work inside the parentheses, so you divide both sides by 2. This is my result, and then I wrote the rule over here, division property of equality. And then I subtracted 4 from both sides, and I got subtraction property of equality to get that final answer. Alright, so that's kind of a busy. Nobody in the real world is going to ask you the properties that you're using to solve the problem, but it's also good to know that these are the steps to get from that complicated problem up there all the way down to 56. Alright. They're throwing a lot at us here today. So, they're talking about 3 consecutive integers. Now, I already learned what an integer, those are counting numbers, 0 and negative numbers, and they want to know what numbers. And so what I do when they say 3 consecutive integers, I just kind of make up some numbers here that are nice and small. And so if I said 3, 4, 5, those would be consecutive integers, okay? And so to keep it simple, if I just said, hey, 3, and I didn't know it was 3 is where we're starting at, I want to say x here. So if x is 3, what do I have to do to x to get to 4? Well, I would have to add 1. So my next one is going to be whatever this guy is. Let's put in another number, 7, 8, 9. If x was 7, so I put a 7 here, I'd have to add 1 to get to 8. Okay, if x was 3, I still have to add 1 to get the next number. So sometimes this, I'm getting a little bit of a cold here, sorry. Sometimes this is a way to kind of see what the pattern here is. If x was 3 again, so in my head I'm thinking 3, what would I have to do to get it up to 5? I would have to add 2. So when I'm doing consecutive integers, and that's what they got here, the first number is going to be x, the next number is going to be whatever x is plus 1, and the next one is going to be whatever x is plus 2 to get the 3 numbers. Now the word is right here means equal, and so 32. So now I have my math problem, and now I'm going to start working to solve it. I'm going to combine like terms. I got 3 x's up there, and I got 1 there and 2 there of units, 3. I like it, and you should probably do on your paper, instead of writing it side by side, do it underneath like this, because that's what they did. 32 minus 3 is 129. 3's on this side cancel out, so they just brought their 3x down, divided both sides by 3, and now they got the first number here is 43. Now remember, they said 3 consecutive numbers. So if x is 43, or on my problem, the next number has to be 43 plus 1, which would be 44. I want to put a 43 there, plus 2 would be 45. So there's my 3 numbers. Now, they said if you put these guys together, 43 plus 44 plus 45, the sum, so I want to add these guys to check it out. 43 plus 44 plus 45. And sure enough, it equals 132. So that's how you do 3 consecutive integers, okay? All right, now I'll get you kind of started on this one. They said 3 consecutive odd integers, the sum, so that means we're going to add them. So again, you might make a nice small example here. 3 is an odd number, the next one would be 5, and the next one would be 7. So if this is 3 is x, what do I have to do to 3 to get it up to 5? Right, you have to say x plus 2. If x was 3, what do I have to do to get it up to 7? Well, I'd have to add 4. 4 plus 3 is 7. So here's my math problem. I want to say x plus 2. If you want to put it in parentheses, you don't really need them, but that's the second term. And then plus x plus 4. All that has to equal 57. All right, put your x's together and get the x by itself. Pause your video. All right, let's see how you did. Here's my example, just in a different location. All right, so I had 3 x's. 2 plus 4 is 6. Got the 6 to the other side. Then I had 3x plus 51. Sometimes you'll see that I don't cross these guys off when they cancel out. I just know they go away. And I got 17. Now you can't just leave it. X is 17, so that's our first number. Then I'm just going to go back up here to my weird example up here, and I'm just going to put 17 plus 2, 17, 18, 19. And 17 plus 4 is 21. So it's a word problem. Answer the question. 3 odd integers, I should say the sum of 3 odd integers are 17, 19, and 21. Okay, answer word problems fully. Okay, now this is what, day 2, I believe it is. And this is crazy, but watch and use your notes, okay? All right, you're going to have chemistry soon. We now have a chemistry teacher this year for the first time in a long time, so kids are taking chemistry. And so this is a lab technician. They need 25 liters of a solution that is 15%. First of all, you got to know how to make percent into a decimal. And so you learned in junior high, the decimal is right there if there's not one, and to make the percent sign go away, you move it to the left. 2 places, so that's really 0.15. Okay, for a certain experiment, but she only has 2 solutions. A solution that is 10%, so that guy's going to be 0.10, and that is 30%. That guy's going to be 0.30. So whenever we do math, we got to get rid of the percent signs by moving that decimal to the left 2 places. How many liters of 10% and 30% solution should she mix to get what she needs? Well, she needs 25 liters altogether of a solution that's 15%. So now, watch how they do that. I want 25% of 15% solution. So there's my 25 liters of 15%. I want that equal to a little bit of 10% and a little bit of 30%, because these are the 2 that I have to make it up. So I don't know how many liters of 10 solution is going to make this 25 liters, so I'm going to put an X there. There it is. But I do know I have to multiply it by 0.10. Now watch this, this is very important. I'm going to use up some of the solution of the 25 liters right here. I don't know how much yet, so that's where this comes from. I want 25, and I got to subtract the amount I already used right here. Okay, so if I use 5 liters here, well then I'm going to have 20 liters, because 25 take away 5 would be 30% solution. So there it is, the amount I need minus the 10% right there, and now multiply 0.30, because that's 30% as a decimal. So now this is where calculator super handy comes in, super handy. I need 0.15 times 25. This is where you need to practice on your calculator so you can keep up and stay with us. I'm getting 3.75. Can't do any math there, so I'm going to write 1.0 x's. But now on this guy, you need to take the distributive property. I need 0.3 times 25. So it's going to be plus 7.5. I need to take 0.3 times a negative x. Positive times negative is a negative, so that's going to be 0.3 x's or 0.30 x's, same thing. Next step, I'm looking at my math problem here. I got like terms. I want to put these 2 guys together. Notice I circled the negative sign there as well, because that negative goes with the 0.3. So I got 0.1 minus 0.3. I want to bring everything straight down that I'm not working with. I want to bring that guy straight down. Now 0.1 minus 0.3 equals, whoops, don't want an equal sign there. Let's see, I'm using blue here, I think. There it is. I got negative 0.2 x's. I want the x by itself, so I can get the 7.5 over to the other side. Math happened. I'm getting negative 3.75 equals negative 0.2x. Last step, let's get rid of, I'm going to do purple here, that negative 0.2. I know a negative divided by a negative is a positive, so we practiced that a week ago. So I want 3.75 divided by 0.2. And I get x equals 18.75. Now, we got to remember what x is. Okay, so x is the 10% solution. Okay, so let's answer the question. They will need 18.75, we need the units, liters of 10% solution, and now we're going to take the 18.75 and subtract that from 25 right there. 25 take away 18.75 because we already used 18.75. And I get 6.25 when I subtract those guys. So I need 6 6.25 liters of 30% solution. To make 25 liters of 15%. Okay? That's a lot of work right off the bat. In years past, kids weren't able to do this until like October or so because of the math skills they didn't have in junior high, and so we had to do a whole lot of review, and they're kind of done with that. So this is a very, very important time of your life that if you're not knowing how to do this and you missed this in junior high, you should start staying after school. Get the help now on how to isolate the variable because it's going to be in your rest of your math career. Okay? Alright, this one's going to take you a little while. Now they want 30 liters of 25% acid solution. How many liters of 10% and 30% should they make to get it? So use that example from the previous page. Pause your video. It's going to take a little time to get this one done. And then let's see how you did. Alright, let's see how you did. I really hope that you tried. Even if you make a mistake, that's okay. So I'm going to say X is the 10% solution, just like on the previous page. I want 30 liters of 25%. 25% is 0.25. I want to have some 10%. I'm not sure how much, but I do know I want the 30 liters all together. So when I come over here, 30 liters minus the amount I already used of the 10%. And that's going to be the 30%. Okay, so I multiplied this to get this. Brought that guy straight down. I took 0.3 times 30, got 9. 0.3 times negative x and got 0.3. Now I collected my like terms. You see how I underlined them here? I got a positive 0.1x and a negative 0.3 for a negative 0.2 x's. Brought my 9 down, brought that guy down. Subtracted 9 from both sides, got a negative 1.5, 0.2, divided both sides by 0.2, and I got 7.5. So that's our 10% solution. So I like to kind of say over here, x is 10%, so I know when I'm all done at x equals. So they're going to need 7.5% liters of 10%. I took that 7.5 and plugged it in over here. Actually, I did it right here. 30 minus the 7.5 of the 10% I already used up, and I got 22.5 liters of 30% solution to make a total of 30 liters of 25%. Wow, that's a heavy-duty problem. This really should be day 2. Like weeks ago when school started, this was day 2 of math in 9th grade. Pretty challenging. You can handle it though. Alright, so let's see what we got going on here. 4 friends are using an online coupon to get discounts on concert tickets. They spent $108 for 4 tickets. What was the price of 1 ticket without the discount? So we have this table here to kind of start helping us out here. And so on this table over here, they bought 4 tickets. They had a discount of $15, but they already know they had 4 tickets times $15. That's their discount amount right there. We know the total was $108, and we need to know this guy here. So they said, hey, you know what, 4 times the original price of the ticket, so that's what we're trying to find out. So it looks like they're going to use a P for price of the regular ticket. And they had a $15 discount, but that's 4 of them. So what they did is they condensed this up a little bit. 4 times the price of the tickets, and then 4 times the negative 15 because they got 4 tickets at a discount, and they said the total was $108. Let's solve this equation now. So they started it out for us to model how the equation's written, but now they want us to finish it. So 4 times negative 15. Get that P by itself. Step by step. PEMDAS backwards. I don't know what 108 take away 60. Do it on your calculator. Just don't write what I got. Sometimes I make a mistake. Well, I'm adding it, not subtracting it. 108 plus 60. We got 168. Next step is get rid of that 4. So I divide by 4. I already got the 168 in the calculator and I got 42. P equals 42. Answers the question fully. Question up here, what was the price of one ticket without the discount? $42, and we need units, dollars. Okay. A lot of times kids will skip the word problems because it's like, oh, I don't even know where to begin. Look at your notes, use your notes. Sometimes on photo math, this would be AI, sometimes it's like, well, I just don't know how to write the equation to get started. You can use those programs to help you, but then study how did they write the equations. So that way when the quiz or test comes along, you know how to do it by yourself. Okay? That would be a totally appropriate time to use photo math when you're just so stuck that you don't even know where to begin. Let's see what happens here. The same 4 friends buy tickets for 2 shows on consecutive nights. They use a coupon for $5 off each ticket. They pay a total of $264 for 8 tickets. Write and solve an equation to find the original price. So I do know they bought 8 tickets, and if we look at that example up there, we'll use the same thing, P, but how much did they get off the coupon for this one? Up here, when we had the ticket price discount, it was a minus 15. Down here, we're going to say it's a minus 5. And they paid a total of $264. So the same 4 friends, 2 shows. So really 4 friends bought it, but they bought it 2 times. So that means 8 tickets they really bought. So they helped us out there for 8 tickets they bought right there. All right, pause your video. It's like 3 steps to get that P by itself. Make sure you answer the question fully. All right, let's see how you did here. 8 times P is 8P, minus 40, 264. Add the 40 to both sides. Let's divide both sides by 8. I got 38. The price of each ticket is $38 without the discount because we compensated for the discount right there. Okay. All right, this is a pretty full day here. This is unusual. This guy here is a little bit of dimensional analysis, which we'll kind of talk a lot about, but they threw it in here, so you're going to have to kind of stick with me for a little bit. Some kids will kind of get what we're doing. Some kids will say, I don't know what you just did right there, and that's okay because we'll kind of do a lot of dimensional analysis here in a little bit. Oh, let's see, LaTanya, she will walk her bike from her house to the bike shop. So here's her house. Bike shop's here. Looks like it's 1.5 miles away to get her bike fixed. If LaTanya's meeting her friend in 90 minutes back at her house, how long can she be at the bike shop and still make it back? So she's going to walk this way at 3 miles an hour, but when she gets her bike fixed and that, she's going to bike back at 10 miles an hour. So that's a lot faster, almost 3 times, a little over 3 times as fast. So let's see how they wrote the equation here. So the walking time, she's walking at 1.5 miles per hour and she's going 3 miles, okay, per hour. Or she's going 1.5 miles, that's the distance, and she's going 3 miles per hour. Now, I left a little space here because I want to show you something here in a second. She's going to spend some time at the shop, so there's my T, and then she's going to bike back. Her distance is 1.5 miles, and now she's going to go 10 miles per hour on her bike, so she's riding a lot faster. And the total time, now this is very, very important. Over here we have hours, and they said 90 minutes. Well, how much is 90 minutes in hours? So what they did is they took 90 and divided it by 60, because all of our units over here right now is in hours. If this was minutes, then I could leave it as minutes, okay? So really it's 1.5 hours. Now, I want to take a big stretch here, because no kid in my 38 years of teaching knew how to do dimensional analysis until we did a whole lesson on it. If this says 3 miles per hour, I want to write 3 miles, because this is the way they really should. Well, they did. I need, in order to do dimensional analysis, I need miles on the bottom right here. So pretend this wasn't here. So to get rid of miles, it's like cross-canceling. I want to put the 3 miles down here, and I want to put hours up here, because I need miles and miles to cancel out. Okay, so again, you're probably not going to be able to follow, but if you do it enough times, watch. So I want to cross off miles and miles, so I still have a 3 in the denominator, but up here I have 1.5 hours now, because 1.5 times hours is hours. That's what I want. Time, I'm going to leave it like that. But right now I want to write 10 miles down here in 1 hour. My ratio is 1 hour, they went 10 miles. So miles and miles cancels out here. So now, watch this going all the way across here. I got 1.5 miles per 3. So I'm going to take 1.5 and divide it by 3, because this is a fraction. 1.5 hours over 3. Miles and miles cancel out. So I'm going to do 1.5 divided by 3. That's 0.5 hours down here. Okay. Plus my time, I don't know what that is. Now I'm going to convert this guy. I got 1.5 times hours divided by 10. So I want 1.5 divided by 10. And I get 0.15. That's a plus sign. This is the curse of T. I hate T's and pluses. This is 0.15 hours. And that equals 1.5 hours. Alright, so we got like terms here. We got 0.5 hours here. We got 0.15 hours there. So let's put those two guys together. 0.5 plus 0.15. I get 0.65. So I have my T still. Plus 0.65 hours equals 1.5 hours. So now, let's get that to the other side by subtracting 0.65 hours. Let's scoop my screen up here. Well, I see we had time, our steps for solving down here, room for solving. Well, I'm doing all my work up here, so we're still good. Alright. Pen catch up because I moved that screen. There we go. So now I still got T. 1.5 take away 0.65. I get 0.85 hours. Well, that answer doesn't really make sense, because I guess you could say that she can stay at the bike shop for 0.85 hours, but really, how long is that? So let's take 0.85, and I know there's 60 minutes in an hour. So I want to know what 0.85 of an hour is of 60 minutes. So let's do that. 0.85 times 60, because that would be a more reasonable answer. And I get 51 minutes. So she can stay at the shop for 51 minutes. I think her name was Tanya. Can stay at the bike shop. Oops. Or you could say 0.85 hours, or you could say 51 minutes. Period. Okay? So, man, that's a lot for today. I mean, a lot. It will start getting a little easier. I look down the road, I'm making some videos of down the road. So every day is not going to be this intense. It'll be a little bit less, kind of lots of word problems, a little bit less word problems, but that's a lot to learn. But you can kind of see what your junior high teachers were telling you. When you go to high school, they expect you to be able to do a lot of this math of collecting like terms and isolating that variable. Okay? All right. Let's go look at the summary here real quick, because each day is going to end with a summary. Let's see on this one. This one's not on your guided notes, but if we had time, this would be a good practice one. Okay? So I chopped that one right out of there. Let's see. So here's some kind of notes that when you're doing your homework and you're having a hard time writing equations, this is kind of how you would do things, and it's just kind of like modeling different things that you might need and might be condensed on your notes and your math homework that you're doing tonight. So go do your math homework for tonight. Make sure you're doing the right one. The middle, when you're on Canvas. Let's see if I can get my Canvas here, because this is our second note. This is very important here. Where are we here? Let's go to Canvas. And I'm talking about the kids that have a modified assignment versus the regular kids, okay? So we're like way down here. I haven't put the video on yet for today for lesson 2. So video lesson 1, guided notes lesson 2, here it is video. So when you come to your homework, you're going to do this one. Regular kids do the Math Excel, practice problem solving. And the Savvy adaptive practice is if you have an IEP or someone we've had meetings about that you have less problems to do, okay? So you guys do this, most kids do this one. You do not do both, okay? That would take you a long time. This 100 points is probably going to change by the time I get to this day. I want to make it homework out of 10, so we're going to kind of practice and see how that's converting over to Infinite Campus. So have a good day, and we'll see you tomorrow.